I want to welcome everyone to the Intro to Cobots presentation. My name is Bob Goosen. I'm the Associate Director of Engineering and Technology Services for Purdue's Manufacturing Extension Partnership, or Purdue MEP for short. Today I'll be providing an overview of collaborative robotics. So today's webinar is being co-sponsored by a couple of different organizations. First of all, being sponsored by OpExchange and several centers within the MEP National Network. So for those of you who aren't familiar with the MEP National Network, it's a public-private partnership that provides a variety of training and consulting services to assist small and medium-sized manufacturers across the U.S. And there's a MEP center in every state, including Puerto Rico. And the centers from Indiana, Illinois, and Iowa, and South Carolina are all work together to co-produce this webinar for you today. So just to give you a quick overview of my background, I've worked for Purdue MEP for the past 5 years, managing the execution of multiple programs to assist manufacturers with advanced manufacturing technologies, Industry 4.0, and smart manufacturing. So over the past 2 years alone, our center has helped over 60 companies with assessing the business cases for a variety of automation applications and providing subject matter experts as needed to help them with scoping and deploying those technologies. I've spent about 20 years in the manufacturing industry in a variety of different roles, from process engineer to a project manager to a production leader. So I've really learned firsthand about the various cross-functional challenges and the considerations that go into a successful technology deployment. So I'm hopefully I'll be able to pass along some of the pearls of wisdom that I've gained along the way. So here's what I'm going to be covering today. And I'm going to start with defining what a cobot or collaborative robot is and how they differ from standard industrial robots. And then I'll share some of the benefits and limitations of cobot technology. I'll also talk about some common applications for which cobots are very well suited. And I also plan to share a couple of videos that really highlight some of the more compelling business reasons for using cobots on the factory floor. And then I'll walk you through really a straightforward application, or a straightforward calculation rather, on how to determine your business case for deploying a cobot on your factory floor. So the return on investment, payback period, I'll kind of walk you through how to do a really simple, straightforward look at that. And then I'll wrap things up with where you can go to get some help on evaluating cobot applications for your company, and then close out with some Q&A at the end. So let's jump into it. So what is a collaborative robot, right? It's a robot that is specifically designed to work safely next to and among people in a shared workspace. Now, why are these robots safe? It's for a couple of different reasons. One is that they have lower payloads than standard industrial robots. So they generally can lift about the same amount as an average human being. They're not like the big industrial robots you'll see, say, in the automotive factories, where they're lifting huge chassis up over people's heads and to the other side of the assembly line. I mean, these robots are really designed to lift very simple human-sized weights. They're also power and force limited, which means that they have built-in sensors that can detect resistance in the robot's path and come to a quick stop to prevent any injury. There are also some other ways for a robot to be collaborative, including speed and separation distancing, where, say, if a robot is operating and the arm's moving within a certain radius, there's a certain scanning technology you can incorporate into the robot that will allow you to have the robot running at full speed when no one's near the robot. And as someone gets close to the robot, say within 7 or 8 feet, the robot slows down to maybe half speed. And then if you get even closer to the robot, say within a few feet of it, the robot comes to a complete stop to prevent anyone from being injured. So there's kind of two ways that a robot can be considered collaborative. In addition to being safe, cobots have some other key characteristics. So they must also be easy to program. And cobots are usually much easier to program than a standard industrial robot because they have a very simple and intuitive user interface. It looks kind of like a handheld tablet. I heard a plant operator say that if you can work your smartphone, you can basically program a cobot. It's a bit oversimplified, but it's kind of along those same lines. It's very intuitive on how you use those apps, similarly intuitive to how you program the cobot. You can actually teach a cobot how to do things like moving objects physically from, say, point A to point B by grabbing hold of the robot arm and moving it to where you want it to go. And you can even have it follow the same path that you showed it. And so it's very easy to program a robot to take a particular trajectory or a path to get from point A to point B. Very easy to set up as well. And when I say easy to set up, I've seen people who are not experienced with robots at all take a cobot that's shipped to their factory and within an hour or two have it doing a simple pick and place operation straight out of the box. So obviously, if you're talking about doing complex operations or doing some integration with other devices, like, say, a vision system or interfacing with a CNC machine, that's going to take a lot more work and programming to get that going. But by themselves, cobots are usually pretty easy to set up. One of the key advantages of cobots is the ability to be redeployed on the factory floor to different operations. You know, standard industrial robots, they're typically designed with a very specific purpose in mind. They're typically geared towards high volume production of single parts or a low mix of parts. But cobot users, they find that they can mount their cobot, in many cases, onto a wheeled platform and move it around from workstation to workstation to do different tasks depending upon what products are being run through the assembly lines or production lines each day. So where standard industrial robots are usually good for high volume, low mix, cobots are really well suited for the low volume to low to medium volume size production runs with a wide variety of products. So when you think of a standard industrial robot, what comes to your mind? What image? You know, most people think about standard industrial robots, and this is the image that comes in mind. The robot is behind a steel cage, right? It's yellow. It's very clear that this is a barrier you're not supposed to cross. And it's because people can get severely injured or even get killed if they get too close to that robot. Now, cobots, on the other hand, look more like this. It's people working next to the robot, right? It's the safety factor of the robots make it so people don't have to have that safety cage, that separation distance in many cases. If you notice, there's a lot less real estate being taken up from the cobot's perspective versus the standard industrial robot. And that's mainly because the robots are so safe that you really don't need that steel cage next to the robot. I'm often asked by folks who attend my my in-person presentations on cobots, you know, what does it feel like to get accidentally hit by a cobot arm? And the answer really kind of depends upon what the combination of speed the robot arm is moving in, how much weight it's carrying, and what the specific settings are on those force and power limiting sensors. But you know, when a unit is properly configured, it kind of feels like if you're walking down a hallway and someone is walking in the opposite directions and you accidentally bump shoulders with them. So you notice it, but it doesn't really hurt you. When we do those in-person demonstrations of cobots, I have a segment I like to call "Get Hit by a Cobot," and it's where I invite the participants to all get up and take turns standing in the path of the cobot as the arm is moving back and forth, and just feel for themselves what the sensation is of getting hit by the cobot. People invariably are very amazed at how fast the robot responds and how quickly it stops, and so it's really an eye-opening experience for them. And it really drives home why cobots are safe to work around people. So this just kind of highlights the topic of industrial versus collaborative robots, right? It's the fixed large equipment, the big real estate, the complexity of programming it versus the small compact size of the cobots, easy to use, easy to set up. Now, I personally consider there to be three main types of collaborative robots. And this is just me personally, different people have different takes on what's considered a collaborative robot. But when people talk about cobots, They usually mean the articulated arms there on the left. They are cobots that have about 5 to 7 different rotational axes or joints. You can put different tools on the end of the robot arm to do different tasks. But there's no real limit to what you can do with that robotic arm. It's really limited by your imagination as to what you put on the end effector to have it do different tasks. Now, another type of collaborative robot is the mobile autonomous robot. These robots are really designed to be mainly material movers. They have built-in sensors and cameras. They've got sophisticated software that enables these robots to dynamically navigate and maneuver in a dynamic workspace. I mean, they can sense an obstacle in their path, and they recalculate where they need to go to be able to get to their final destination. So they don't have to follow a specific line. I know a lot of people are familiar with some of the old mail robots maybe that used to see in the offices of companies, where they would follow sort of a magnetic strip or a line on the floor, and if something was blocking its path, like a person, it would stop. It couldn't move around that person. So these robots are more autonomous, which is why they're called autonomous mobile robots, in the sense that they can quickly reroute themselves and deliver the product where it needs to go. I actually have a video, and I'll share in just a few minutes, that will show these mobile robots in action. The third type of cobot falls into the wearable robot category. These are more commonly referred to as exoskeletons, and they're designed to reduce muscle fatigue and help with ergonomically challenging tasks. Now, these they're different exoskeleton models. Some use spring-actuated motors, and some are actually electrically powered with lithium-ion batteries. These are very useful for things like overhead assembly line work. I see these used not too infrequently in automotive companies, where the workers are lifting heavy components up, and they're installing them on a car chassis as it's moving down the assembly line. So they're spending most of their days with their arms like this up in the air, moving and installing parts. And so you can imagine the amount of fatigue that their muscles have at the end of their shift. So these wearable robots, or the exoskeletons, are really designed to take that burden and make it easier on workers. So I really shared this information to give you some perspective on a few of the different technologies that are commercially available out there in the market, but I'll be spending the majority of my presentation today talking about those articulated arm cobots. Those are more the traditional cobots that people think of. There are also lots of end-of-arm tools that can be purchased off the shelf that you can just snap into place on the end of the cobot arm and very quickly have it up and running. Some of the more common grippers are for activities like pick and place, for machine tending activities, packaging and palletizing, and those typically come in 2 flavors. There's the vacuum gripper, and that can either be done with a vacuum line that's run externally to the gripper, or there are some grippers actually have a built-in vacuum generator so that the vacuum can be generated there at the end of the arm to pick up the object itself. Then there's also electric and pneumatic type grippers, the typical pincers that will just grip the component and move it to where it needs to go. But then there's all sorts of specialty tools as well that you can install at the end of the robot. It goes from screwdrivers and sanders to soldering irons and welding torches to inspection cameras and more. So it's really just, it's limited by your imagination in terms of what you can put at the end of that arm. One of the main cobot manufacturers is called Universal Robots, or UR for short. And they have a platform on their website called UR Plus that you can actually go to and see all the different off-the-shelf tooling that you can purchase to put at the end of their cobots. And there are several other cobot manufacturers that have a similar listing on their website of different off-the-shelf tools you can use. So the reason why this is important is because it makes it even easier for your company to be able to deploy a cobot, so you can just buy the gripper off the shelf without having to custom design it. All right, so here is some examples of the more common applications that cobots are used for. The ones I most frequently see cobots being used in the factory are for pick and place and machine tending, as well as for packaging and palletizing. Those really tend to be the sweet spots for a lot of cobots, mainly because they're very straightforward applications. But really, I've seen cobots used for a wide variety of applications, from things like flipping burgers to doing brain surgery. It's amazing what these robots can do because of their accuracy and their inherent safety and working around people. But the listing here goes on to cover things like screw driving, assembly work, drilling operations, spray painting, deburring and sanding. I've also seen that done a lot in factories. So really, there's lots of different applications, and if you have a specific application in mind and you want to know if a cobot is able to do it, all you really have to do is go out and look at YouTube. Just type in the application that you're looking for, that you're interested in, and then follow it with the word cobot. And then when you hit enter, you usually get several videos that will pop up that show a cobot doing that particular application. So I encourage you, after this webinar, if there's something that's on your mind you want to try, just go to YouTube and see if there's a cobot example out there that shows a cobot doing the task that you were thinking of. People, in fact, the reason why there's so many videos out there on YouTube is because people are very proud of their cobot applications. When they get their cobot deployed on the factory floor, they're often taking videos of it, trying to highlight it, and they use it as promotional materials. So you tend to see these guys posting a lot of these videos onto YouTube for that reason. So the target market for cobots. My general rule of thumb is that these cobots are really well designed for manufacturers that have a product family mix. So maybe a common product that has different configurations, different variations on it, where you have some fairly low to medium volume runs. If you've got just a very small volumes and just thousands of different parts that you're running through with very low volumes, the programming to get the cobot to handle all those thousands of different parts probably be pretty intensive. So if you have a production volume that you're going to be running for several days on one part, but then you're going to switch it over to another part and then run a similar amount of volume, that's where cobots can usually come in handy and be well adjusted to handle that volume. That's when you really get the return on investment, is being able to keep that cobot running versus having to switch it over to do different parts. But again, because of the grippers, if you're not making it do different tasks, if you've got this one gripper and you're able to handle, say, a machine tending operation with one gripper, but you can probably handle multiple different parts with that one robot, just in the fact that it's picking up different, say, blanks and putting them in the machine and just running different programs on the CNC machine. So, these robots really can handle a wide variety of parts. It just kind of depends upon your specific application. From different perspectives, there are different reasons why you might want to consider cobots. If you're a business owner and you're always thinking about the finances, right? You're looking for that fast payback on your investment. The average for a cobot is typically less than a year for folks who deploy this technology. So it has a very fast return on the investment, very fast payback period. If you're a plant manager, the problem I've heard most often is they can't fill their shifts. You just can't find skilled workers to do the work. They have people who they can depend on, but oftentimes they're having to pull them off the line to handle a different, maybe lower skill task because the person who was running that line didn't show up that day. So to taking one of their more valuable, experienced employees and putting them on something that they really is underutilizing their talent, right? So it's a great source of frustration for managers. I know, especially with the COVID-19 situation, folks are saying, I'm having a really hard time with absenteeism, and folks just aren't showing up because they're scared. And a lot of them are turning to automation as a way to get around that, especially when you think about some factory lines where having physical separation is really challenging when the workstation has been designed to have, say, a couple of operators working side by side on different tasks. So you can't really separate people effectively when the workstation is not designed to be that way. That's where Cobot can come in. You can put the Cobot next to the person, and where you had a two-person operation going on, now you've got a Cobot and a person doing all those tasks together. And it can make a big difference in terms of keeping the productivity up for your company in the light of a lot of uncertainty around absenteeism. And then from an operator's perspective, there's a lot of folks out there who are stuck in jobs that they hate, right? There's a lot of manufacturing jobs that just aren't that glamorous or exciting to do. They're dull tasks. In some cases, they're dirty. They're covered in grease at the end of the shift. I know one operator who worked in a pulp mill, and I think it only lasted like a few days. He couldn't stand the smell. And there's also some dangerous jobs too. You think about the work in a steel foundry, for example, and the risks that are involved with the high temperatures and the molten metals that are involved in that. So cobots are really a good way to alleviate a lot of high turnover positions that involve doing dull, dirty, or dangerous tasks. So we often find that when cobots are deployed on a factory floor, there's always or not always, but frequently there's a lot of resistance from the operators, right? The folks on the factory floor, they're like, oh, we don't want the robots coming in and taking our jobs, and keep it out. But once they get the robot in and they see how it's making their jobs easier, the operators actually become the biggest advocates for doing more automation. We start off with a deployment of a robot, a cobot in one work cell. We're doing one task. The operators see it working, and they're like, could you figure out a way to automate this job over here? I really hate doing this job. Can you find a way to do that? And then when they see that the cobot can do that task for them and free them up to do something else that's more enjoyable or less difficult, strenuous, then they're like, okay, where else can we put this robot? Where else can we deploy it on the floor? So it's amazing the perceptual turnaround that you have with operators once they actually have the cobot there on site. For companies that are looking at retrofitting your existing production lines, real estate can often be one of the more challenging constraints for automating. And the standard industrial robots with the steel caging and all that just often isn't practical to install. But with cobots, you can mount these things on the side of a CNC machine. You can mount them up on the ceiling and have the arm move down to do its task and then move up out of the way. So these robots are very conducive for doing retrofits on assembly lines or production lines on the factory floor. All right, so video time. This is what I love the most, sharing videos about the cobots, because you get to hear from the manufacturers themselves about the cobots. You get to see them in action. I like to do factory tours where you can actually do dynamic interactions with companies who have deployed these cobots. But of course, obviously with COVID considerations, we're doing more of these webinars. So videos are the next best thing. The video really highlights some of the key concerns that manufacturers have, and the talking points that the man in this video brings up, see if any of these sound familiar to you, if they ring a bell. Because I know that there's a lot of companies that struggle with the same issues as this company.
Based in Dallas, Texas, All Access Machining is a small machine shop struggling to automate the operation of old machinery. When the company discovered the open integration architecture through the Universal Robots Plus platform, they were quickly able to automate 6 different operations.
We found that there was a lot of downtime on our equipment. It drove me pretty crazy when all the guys were out to lunch and I would see none of the machines were working. They'd go home at 5 o'clock, we'd have a skeleton shift, and I would have only half the machines that were working. This was really costing me a lot of money. It was costing me orders that I couldn't get out the door and to my customers on time. And so that's why we decided to look for automation. The problem was we had all this legacy equipment. We found that Universal Robots has an incredibly good platform called the UR Plus program. There's the software development kit, also known as SDK, that allowed us to address this entire legacy issue, so it didn't matter how old the machine was. We would have a way through our controllers to be able to interface old machines to the new technology. We bought a UR10 immediately, found out this was going to really have great applications for machine tending, sanding, deburring, inspection, part marking, and wire EDM.
We could not even spell robot. We had no automation. Getting our first robot and the ability to already start to integrate those machines into our solutions was unbelievable. We would not have been able to do that if it weren't for the fact that Universal Robots has this fantastic website. So to get started with the Universal Robot SDK, you sign on, you become a developer, and you're then given the ability to download all this capability.
In addition, UR Plus is an environment that allows us to go find supplementary tools to help implement the robotics in our operations. There were force sensors, grippers that we were able to quickly buy off the shelf and integrate into our operations. We had a particular job with one customer. It was a job that under normal circumstances was going to take 4 to 5 months of runtime on one machine under the staffing that we had. We took the robot, put it on there, and we actually delivered that part almost 2.5 months early because of all the additional machine time. What that meant for the bottom line is probably about a 60% increase in profit on that job alone. It was to the point that the ROI on the robot was probably about a 4-month return. Other benefits is an improvement in our quality because of the consistency the robots deliver. On the sanding operation, we had an elderly operator, and it's a lot of muscle to sand a part by hand. I was watching him on the monitors one day, and on his own, after he'd gone through some basic training at the UR Academy, he picked up the pendant and started to program it to go ahead and sand the part. And I tell you, I've never been more proud to see one of our employees learn a brand new technology and actually improved his skills and going to improve his whole lifestyle, not only from what he has, but his earning capability as well. To support high mix, low volume environment, we have to achieve quick changeover. We have gone back to the UR Plus program that will allow us to put different tools onto the part for different deburring and sanding operations, and everything can be done very quickly.
We can't dedicate our machines to one particular part. Another advantage of a collaborative robot, I can move it to another location and reuse it.
We've been so successful in implementing the robots in our factory, we realized that there's an entire market here. We created a new company. What All Access Robotics will do is actually go to all these other machine shops, and we will integrate the robots into any legacy machines, because this is what will really drive manufacturing in the United States.
Okay, so essentially what this company was dealing with is that, he had some old legacy equipment, and the machines were underutilized. The workers would go home at the end of their shift. I think he was only running one shift a day, maybe two. But with the overnight, he just had a skeleton crew, and the machines, maybe only half of them were even running. So he was missing out on sales. He had to turn down orders. He had late shipments because he couldn't fully utilize his equipment. The company had no previous automation experience. They had some operators who were a bit elderly, and so there were some physically demanding tasks that they were hoping to automate. So they started deploying these cobots on the factory floor, and they had some jobs that they were able to get a much faster completion on, where it was taking their manual operation maybe 6 to 9 months, I think it was, or 4 to 5 months to complete. They were able to knock out in maybe 2 months. So they had increased profits as a result of that. They also saw their quality improve because the robots are consistently accurate in terms of how they're performing their task. Whereas as a person their attention can wander while they're working the production line. Their muscles can get fatigued, so they're not, maybe if they're doing a drilling operation or a screwdriving operation, they're not pushing in with the same amount of force at the end of the shift as they were at the start of the shift. So there's a lot of benefits there for that improved quality. And then they had an operator who made his own job easier by programming the robot to do a sanding operation that he himself was doing. So it made his job easier, just picking up the teach pendant, the tablet, and programming the robot himself to do the task. and then they're able to put the robot on wheels. I don't know if you're able to see that. They have some casters on a mobile platform that they could lock into place, and they would just unlock the casters, roll it around to another station on the factory floor, and then lock it into place and have it going on the next task. So they were so successful at using these cobots in their own factory that they actually started a side business called All Access Automation, and they're actually helping other machine shops integrate cobots on their factory floor. So actually turned into a whole new business model for them. Another one too on the mobile industrial robots, or the autonomous mobile robots, is a case study from Metro Plastics. Again, I've got a link here on the slide. But this one was really interesting. It was a company that was a small family business. They wanted to retrofit their existing operation and get some automation going, but they really weren't sure where to start. But they realized they had a lot of issues with material movement, and parts were sitting on at the workstations, the finished parts, waiting to go to quality for inspection. And it was creating some bottlenecks because the person who was supposed to go around and gather those boxes of parts and take them to inspection, they were slow, or they got distracted sometimes talking to other coworkers, and they were finding that some of the production runs, if they had a quality issue, they weren't catching it early enough to stop the production mid-run and avoid all that rework and scrap. So they looked at automating the material movement side by using a mobile industrial robot.
Metro Plastics is a family-owned business. We specialize in custom plastic injection molding and injection mold tooling. Our average job runs for about 2.4 days, and it doesn't give us a lot of opportunities to automate. So we have to look in other areas of our different processes. Engineering brought forth an option, which was the mirror robot, which didn't need any wires in the concrete. It didn't need magnet pills or anything else to guide it. And it's autonomous, and it was basically about half the cost of the other solutions. It was kind of a no-brainer for us.
We have set the robot up to loop our floor. It currently loops every 10 minutes, and we have it stopping at each press currently for 30 seconds. When we first received the robot, we had to map the floor, which was as simple as actually driving it. To actually map the building and program it honestly took us about, in total, 2 to 3 hours. I've had to change the programming a couple of times. Honestly, it only takes about 3 clicks and it's done.
Before the mirror robot, our job was kind of hectic. By the time we'd get out there, there might be 3, 4 boxes sitting there that have been inspected for a couple hours or so.
By taking the finished product directly to quality, box at a time, they can look at every box and find problems sooner. And we have eliminated the need to go back and look through a bunch of product to find out when the problem started. So that's been a real hidden benefit. We basically eliminated fork truck traffic completely on the production floor, and much made it safer and cleaner.
Since we've had the mirror robot, I can focus more on my task at hand, checking the product, and not have to worry about how long it's going to be in the way, or when a material handler could come along and move it for me. I'm amazed by the capabilities. How much it can move at once is amazing.
We're planning on converting to tablets at each press, and it'll be an on-call system. This way operators don't have to wait. They can just call it as required. It can come out, pick up 1 box, pick up 2, and then just head straight back.
We don't want to invest in a solution that is not going to be part of the future. We've developed some custom web-based software which we call Metro Connect. We can also integrate that communication with the mirror robot. So the mirror robot doesn't have to put mileage on the wheels if it is not called for.
Future plans will enable us to have the robot pull up to each press, the conveyor turn on, and parts on the conveyor roll straight onto it.
Even before we finished completely moving in, my team had the mirror robot going, and I had some customers come in, and their reaction is they're stunned.
Okay, so, and one of the things they talk about in the video is that when they bring customers in to their factory floor and they see that robot making its rounds, it impresses the socks off the customers, because they see the automation and they're like, wow, you guys are really high tech. And they don't understand how easy it was to deploy that technology. They see the robot and go, yeah, wow, you guys are automated. And I've heard this from multiple different customers, companies who have installed cobots on their factory floor, where they actually use that as a sales method for driving new sales. They bring a customer into their factory and they show them the robots, and make sure the robots are running, doing the tasks on the machines. The customer sees the robots and they're instantly thinking automated. They've got reliability, they've got quality, I can trust these guys. So it's surprising. That was one of the unanticipated benefits of cobots in my mind, was that additional sales opportunity, just by the fact that the company is now automated. I had one client who also, who we talked about automating, and when he finally deployed his solution, got running on the factory floor, he had some big customers that come in and do those quality audits, right? Where they send some representatives from the headquarters, they come to the plant and make sure their suppliers are following all the procedures. Well, he'd had problems with his auditors in the past, where they'd written him up on all sorts of issues. After he installed his cobots on the factory floor, and the auditors came in, he got such glowing reviews on his use of technology. And God, your quality is really going to take off because of this. We're really impressed. He got great marks from the auditors after he did that. So it's some of those intangible benefits that you sometimes overlook when it comes to putting automation on your factory floor. So a few other reasons to consider cobots. There's actually an MIT study that was done that looked at human-robot interaction and collaboration. And the study found that humans and robots working together are actually about 85% more productive than either a robot or a person working alone. And the reason for that is that robots are really good at doing repetitive tasks well, doing it accurately and repeatedly over and over. Whereas people are more good at are better at problem solving, right? And going around obstacles. So where a robot might get stuck if there's a jam in the part feeder that's feeding it the blanks to say put in a CNC machine, a person can walk up that thing, oh yeah, and bang on the side of the feeder, or block the feeder and get it going again. So that's really where that synergy between having humans and robots working together can really bring benefits on the factory floor. Because these robots, cobots, don't lift heavy payloads, superhuman payloads, they can typically just be plugged into a standard wall outlet. They don't require a whole lot of power to lift 11 to 20 pounds worth of weight. They're also, as we talked about earlier, very redeployable. That's one of the key benefits of these robots. Reliability, not only just in terms of accuracy, some of these robots can have accuracy of 0.03 millimeters when it comes to hitting their targets. So very tight tolerances around their accuracy, but they're also not designed to have routine maintenance. You don't have to oil the joints, anything like that. These units, really, I think the only preventative maintenance is just the filter that's on the cooling fan for the motor of the robot. So they can operate very reliably for up to 45,000, even longer lifetime hours. It just kind of depends upon how much weight you're putting on the joints and how often you're running them. But people have had cobots on their factory floor operating without any issues for over 8 years that I've seen, and no problems with the robot. And then, as I mentioned earlier, easy to see if a cobot can do a task that you're considering just by going on YouTube. You could also reach out to your Purdue MEP center or to local vendors or distributors and ask for product demonstrations. They can often bring these units to your factory floor and give you an overview of these robots to your company leadership or to your accountant who might want to take a look at the business case for these robots. So yeah, consider these additional reasons for cobots. But I don't want to be like all rosy here and talk about these cobots are all great. There are some limitations to cobots. They do have limited payload capacity. They're not going to, like I said, lift the cars over their overhead. They're going to lift very human-sized weights. So most cobots will max out at around 20 to 35 pounds of weight. Their Fanuc is actually one that goes up to, I think, 77 pounds. I've seen one from a European company that goes up to, I think, 110 pounds. So it's those are kind of exceptions. The majority of Cobots in the marketplace are about 20 to 35 pounds. And of course, obviously, the heavier you go in payload, the more expensive the robot, just because they need stronger motors to be able to lift the weight. Same thing with the reach. You know, most robots have about 1 to 4 foot reach on them. That's pretty typical. I've seen some robots by themselves that have a reach as far as 7 feet. But again, the longer you want to put the arm, the farther out you want to extend it, that will drive up the cost as well for the robot. A lot of companies get around the reach limitations by installing what's called a linear 7th axis, and that's the picture that's shown up there on the screen on the far right, where the robot's sort of on a sliding rail, and so the robot can move from machine to machine just by sliding along the rail and then doing the task it needs to do. So you overcome that reach limitation just by having that additional 7th axis. It's a great solution to have if you find that the reach that the robots are built with aren't enough to do the tasks you're looking to do. And then lower operating speeds. That's often the biggest challenge. If you've got you know, something that we need of high throughput, high volume of production, cobots aren't the right solution for high volume production. What you want is something that can kick out parts really, really fast. And robots are the cobots, because they're designed inherently safely, they're going to move at slower speeds so that it doesn't hurt someone if they bump into it. So they're going to be a little bit slower than what you'd be accustomed to with a standard industrial robot. And then there are some applications where you can't make the application safe for people to be around. Say, for example, you put a welding torch on the end of the cobot. You still wouldn't want someone standing next to the robot, even though it's inherently designed to be safe. The torch is going to be a safety hazard. Same thing if you put like a surgical knife on the end of the robot. You would want to have people near that robot, even if the robot just gently bumps someone, that could cause severe injury. So you really have to do a safety risk assessment for your application to make sure that cobots are suitable for the application you have in mind. And there's lots of documentation out there on the process for doing safety evaluations. All right, so all great information, right? But let's talk money, because that's ultimately what it comes down to. If the cobot doesn't work out economically, then what's the point? So the most common question I get is how much do these units cost? And of course, as I mentioned earlier, the price depends upon how much you need the robot to lift, how far the robot arm needs to extend. The pricing also depends upon which cobot manufacturer you want to go with and the brand that you choose. Universal Robots is the market leader in this space. Most of these slides I've got permission to use from Universal Robots. They probably have about 60 to 70% of the global market share in cobot technology. So it's they're sort of the 800-pound gorilla when it comes to cobots. Their robots are roughly $35,000 on the low end for a cobot with about an 11-pound payload and maybe 20 inches worth of reach one direction, up to about $65,000 for a cobot with a 35-pound payload and about 3 feet of reach one direction. Now, other brands that I've seen, their price ranges from about $15,000 on the low end to as high as $100,000 for one that can lift 100 pounds. So it really depends upon your application, and these are all MSRP prices, so you might be able to get some discounts from distributors if you buy several robots at one time. So just to give you some rough ballpark numbers on the cost of these robots. Of course, obviously, additional things like grippers, vision systems, other systems you want to integrate with that robot will add to the cost of the deployment. So the rule of thumb that I use is about 2 to 2.5 times the purchase cost is what you'll end up typically spending on the installed costs for the robot. So take purchase price multiplied by 2 or 2.5, you've got a ballpark number for a total installed cost. Again, depends upon how much you want to do in terms of systems integration. It could be higher than that if you have a lot to integrate. Now, if the price tag scares you for the cobots, then you'll be glad to know that there are a couple of different options, such as renting the robot or leasing the robot from different companies, so you don't have to put all that capital up front. You can use it as an expense versus a capital expense, the operational expense. You don't have to spend all that capital up front. You can maybe, in some cases, try before you buy. So there's options out there, and our MEP Center is helping companies navigate some of those options on the low to no capital options for Cobot deployment. So let's say you're considering buying a Cobot, and you want to have a rough idea of the financial cost, if it makes sense or not. Here's a method you can use to evaluate that opportunity. Very straightforward. So let's, I don't know if you can see my cursor or not on the screen, but say you have the labor cost for your operator per hour, and this probably is just the $18 an hour, it's probably just the flat salary. What you really want to do is incorporate all the total full burden costs for that operator, including all the benefits and fringes, so things like medical and health insurance, if you have any retirement contributions to their 401ks, you know, you can add all that into that total labor cost. How many hours per shift do you have? How many shifts per day? How many days per week are you running? How many weeks per year? So you take all that, and how many operators are doing that task per shift. So you basically just take all those numbers that you have access to, multiply them together, and you get the yearly running cost, which in this case, example here, is $108,000 for an $18 an hour operator. Divided by 12 to get your monthly operating costs. So it gives you a rough idea of here's how much I'm spending just on the labor piece alone. Now to determine if the cobots make sense or not, see if I can get down to the next slide here. What you want to do is take your robot investment and divide it by your monthly running costs. So in this particular example, we're going with the low end on the universal robot side, say $35,000 cobot, lifts about 11 pounds. Factor in some additional hardware, things like the end-of-arm gripper you want to buy, maybe an extended warranty, bring total cost of investment, total purchase cost to $45,000. So you take that total investment divided by your monthly running cost, which if you remember from the last slide was $9,000. 45,000 divided by 9,000, 5 months. That's how long it would take to break even. Okay, now say, okay, well, that's just the purchase price. Use my rule of thumb for 2 to 2.5. So you multiply that purchase price, that total investment by 2, you get $90,000. So now your break even in months is now 10 months. Still less than a year, which a lot of companies would say that's pretty good return on investment if you are able to take it and get payback. You get to recoup your investment within a year. Now, if you want to look at the annual savings of that, your first year you're going to have to take out your investment costs. So in this example, it's $108,000 was the yearly operating cost minus your investment, so you got $63,000. But then every year you're saving that $108,000 on the manpower that you would have paid otherwise. So you can then just add in $108,000 each year. So you can see at the end of 5 years, here's your total net savings of $487,000 right there. Again, very simplistic method of looking at it, of calculating the ROI. Obviously, there might be some other costs involved. If you want to go with this turnkey systems integrator, you know, you got to factor in all the costs of the additional equipment. The time factor may be involved. That might be something you have to financially consider, of maybe having to have a work cell offline for a week while this thing gets installed. But then there's also other benefits to consider as well. Things like improved quality. If you're expecting to reduce scrap, how much is that scrap worth to you? If you have, say, a 10% reduction in the scrap rate from that work cell. What about the training costs? If you have high turnover for that position, and you're going through and training a new worker every month on that same task, and the person leaves and goes somewhere else, there's a lot of costs associated with training a new employee. So factoring that into the savings as well. So you know, there's trade-offs in terms of both the things you can consider on the pro side and things you can consider on the con side to do the full economic analysis. And the MEP Center Network can help you navigate some of that financial calculations if you want to do a deeper dive. But just to get a ballpark number, this methodology is usually pretty good to get a sense of does this make sense or not for your operations. Okay, real quick, here's the average payback in terms of months for the application. So average is about 10.5, but you see it varies somewhat depending upon application. For quality inspection, payback period can be pretty fast and averages to about 4 months. On the tail end side, things like assembly operations or lab analysis, that can be over a year. There's one case where a company installed a pair of robots and was able to get their payback within just over a month, just from all the savings they had from those robot deployments. And then when it comes to deploying Cobot, a lot of companies want to start with their most complex tasks that they have the hardest time doing. Not the best place to start when it comes to your first automation deployment. What you want to do is really look for those opportunities on this chart here that are simple for your company versus being complex and have a good ROI, return on investment. So there might be a pick and place operation, there might be a machine tending operation that can be straightforward to do to really get your feet wet with a automation deployment. Use that as your first choice, and then once you have that comfort level established with using Cobot technology, then you can start looking at, okay, what are some other easier deployments for that technology and get those going. And then once you have that, you really feel comfortable with all these applications, you can start moving into more complex applications with high ROI value to them, and get those really complex challenges addressed within your factory floor. Now that you have a good understanding of what you can do with that technology. And of course, if it's complex and it has a low ROI, don't bother with the robotics. It's not worth the hassle. All right, so where can you go to get help with Cobots? If you're in Indiana, Illinois, or Iowa, you've got access to a federally funded program called iSmart through the MEP network. Your MEP center has some opportunities for services that can help you with identifying automation opportunities, with developing the business case for specific applications. We come in and do an assessment on your factory floor and give you a report on those economics. We can connect manufacturers with additional automation resources and help get your factory floor ready for that automation deployment. So our emphasis is really helping on companies get those quick wins, the fast payback on automation deployment. Now in South Carolina, you've got the South Carolina MEP Center, and they also have resources available for helping with consulting in this area. I'm just not as familiar with their services as I am with iSmart, since I am myself located in Indiana. But your local MEP center is a good place to start for assistance with automation. As we don't have any horse in the race when it comes to automation technology, we're not advocating any particular one technology. We try and find the platform that works best for your needs. So we're not trying to sell you on any hardware or software system. It's just, this is the options. Here's what we think might work best for you. And again, the good place to start is with the automation assessment, implementation evaluation, to help you figure out that ROI and the suitability of potential applications. All right, so I know we're about 5 minutes left. What did we cover? And hopefully I went through all these different topics that I mentioned at the start of the presentation, and really give you a sense of what Cobots are, what they're good for, what their limitations are, and how to do a business case on the Cobots. And of course, where to go to get help. With that being said, if you want more information, here are some contacts you can reach out to within your different states to get assistance. And of course, if you want to do a quick screenshot of this would be good to capture this slide so that you can reach out to these individuals if you want to follow up with some more questions. And then from the South Carolina MEP, here's the regional VPs. And Mike, I don't know if you want to comment on the available resources at South Carolina MEP.
So this is where, again, like you said, each of the regional VPs are the people that you should go to get help. They've got resources that they can apply. They got additional. It's not the same grant that you have, the federal grant, but they have other grants available, applicable, that they can apply, and they can help assess the situations at the plant, because robots won't always be the best solution, right? So it's not something where you want to just throw a robot in to gain efficiency. If you're throwing that into already wasteful situation, it may be adding to the waste. So they can help assess the situations.
Excellent. Yes. And we have lots of different consulting services with the MEP network. Lean, Six Sigma. Yeah, one of the things you don't want to do is automate your waste, and that's definitely a key concern when it comes to automating. Don't automate your waste. Make sure your design is well suited. So I'm going to stop sharing right now and go back to the chat window and see if we have any questions in the chat. Okay, so let's see here. All right, so a question, Cobots in harsh environments, heat or dust. So yes, The cobots are rated for IP54 settings. They also are available, they have sleeves you can wrap around the robot arms to make them more suitable for a hotter environment, or say a spray paint environment where there's the spray paint particulate matter that's in the air. So they do have some potential options to help them adapt for harsher environments. Dusty environments can be a bit of a problem because the cooling fan has a filter on it, so it can create problems with the cooling fan motor. So dust can be a bit of a challenge, but again, you have to look at your IP rating on the application, on the environment, and make sure that the cobot is suited for that particular application. These collaborative robots, a niche market. Yeah, they don't have quite the same volume as the standard industrial robots like FANUC and ABB and others, but definitely there's that place for cobots when it comes to using them on the factory floor in the situations that I mentioned in the presentation. They definitely have advantages over standard industrial robots, but definitely they have different places, standard industrial versus cobots in the marketplace. Another comment that Precise Automation is cobot that is the fastest on the market. I'm not too familiar with Precise Automation and the cobot that they have on there that they utilize, but definitely the speed of the robot depends upon the application and the payload. So while they say they may have the fastest, under what conditions you would have to ask. Because obviously if it's got a very heavy weight on the end of it, it's moving very fast, it could definitely cause some harm to someone if it bumps into a person in his path. So fastest is definitely a relative term that is application dependent. The data for the average payback, that comes from self-reported information from clients who have deployed cobots on their factory floor in these different applications. So that data was compiled by Universal Robots for that slide. You see cobots, you comply with ISO 2018. There actually is some safety standards out there for ISO. There actually is a technical specification for cobot safety. It's TS 15066, and that has a lot of information about how to do how cobots are designed to be safe from an applications perspective. There's a separate ISO standard for cobots and their design, like in the factory, the manufacturer is building a cobot. But for actual application, the technical specification 15066 is a standard for that, or it's not an official standard, it's a technical specification for that. So key differentiator there. And yes, we can get a copy of the presentation. I think we'll also have the webinar recorded. The webinar is being recorded, so you have that available to you as well, the full video. And I got another question here in the chat. How many inches per minute can the arms go and still be considered cobots? Again, that's application specific, depending on how much weight is on the end of the arm of the robot. There's some force calculations that you may have to do in the risk assessment. Of course, force equals mass times acceleration. So the more mass you have in the arm, the slower you will need to go in order to prevent injury. Now, again, there are other options you can have to help the robot move fast and still not hurt someone with a heavy weight. That speed and separation distance I mentioned at the start, where you can have the robot running at full speed and someone standing, say, 8 feet away, but when they get closer, the robot goes down to 50% speed. They get closer, it completely stops. So that can be another option to get faster cycle time on your cobot by having that additional sensor capability installed in the robot. All right, so it is officially 1 past the hour. I know I'm past my time. Thank you again for your participation today and your attendance. If you have any questions, again, feel free to reach out to me or to the contacts that are listed on the slide, and we'll be happy to help you out with evaluating automation opportunities for your own company. Thank you again, and have a good day.